At the time, October 19th, 2017, I was at a meeting of the American Astronomical Society. Now, every morning before going to the conference talks, in my hotel room, I would actually review the previous night's data.
Robert Weryk downloaded images recorded in Hawaii by the Pan-STARRS telescope.
There was one object in particular that caught my attention. Predicting where the object should have been on previous images, the object wasn't exactly where it was supposed to be. This was very puzzling to me.
What caught his attention was a ball of light rocketing towards the sun.
So I called my colleague to ask for their opinions.
Hi, Richard. Yeah, I'm looking at last night's data.
It suddenly accelerated, tripling its speed. Initially, it followed a steady path before abruptly changing direction toward Earth.
With their feedback, suddenly it clicked. This object was very special. It actually wasn't gravitationally bound to our sun, meaning it had originated from outside of our solar system. It was an interstellar object. This was very new, never having been seen before.
The discovery immediately sparked the interest of astronomers worldwide. Telescopes everywhere turned towards this strange object to try and understand what it was, where it came from, and where it was going.
No gas, no dust. It just looks like an asteroid.
Perhaps it is a spaceship or a probe. We have to put that possibility on the table.
We gather clues, deduce facts, and craft hypotheses. Scientific research is actually an extremely difficult police investigation since it challenges us with a huge number of parameters.
This unknown interstellar object was on a trajectory that would bring it close to Earth. It was observed intensively by numerous telescopes for 11 weeks before it drifted away, out of sight. Robert Weryk's discovery caused a stir in the scientific community due to its unprecedented nature and the fear of a catastrophic collision with the Earth. Research is still ongoing to determine the exact nature of this unknown object. Is it a one-off? Or is it a precursor to future threats? Atop the peaks of the Hawaiian volcanoes, around 20 of the world's most advanced telescopes scan the sky. The Pan-STARRS telescope sits on the summit of the Haleakala volcano, 3,055 meters above sea level, on the island of Maui. While examining images recorded by this machine from the night of October 19, 2017, Robert Weryk spotted this unknown object. Every night, when conditions are clear, its ultra-high-resolution camera scans the sky. Its observations continue until daybreak. The data is then analyzed by astronomers.
Pan-STARRS, our mission is to find near-Earth objects, NEOs, we call them, which are asteroids that are going to come very near the Earth's orbit and possibly impact it. And we want to stop that. We want to find them before they do that. So for that, we need to survey the entire sky multiple times and to catch them moving. So we have a large field of view, which enables us to do this more quickly than other telescopes, which aren't optimized for this kind of work.
Scientists need as much data as possible to understand this interstellar object. Robert Weryk and Richard Wainscoat, an astronomer specializing in small celestial bodies in the solar system at Hawaii's Institute for Astronomy, bring in Karen Meach. As an astrobiologist with vast experience, she's an important voice.
Richard Wainscoat called me on a Sunday afternoon, October 22nd, to tell me that they had discovered an object that they thought was coming from outside our solar system. I was surprised, and my first thought was I was a little bit annoyed because I had just gotten back from a long trip and was ready to have one day of relaxation. But then as I started to think about it, I got really excited because this is the sort of phone call that every solar system astronomer wants to get, a discovery of something brand new that we'd never seen before. The first thing we had to do was to get some telescope time because it's very competitive to get time on the largest telescopes in the world. So we requested time from directors who hold out a little bit of time for unexpected discoveries. We got time approved on Monday, so it was an intense week where the data started to come in. We had a whole team of people looking at the data, analyzing it, pretty much working 24/7.
The astronomers are now certain that the sighted object is indeed an interstellar visitor. Its discovery has drawn widespread attention. Scientists can't keep referring to it with vague, shifting terms. They must find a name which will identify it unequivocally. Nader Hagigi Pour, president of the Working Group on Star Names within the International Astronomical Union, explains why.
However, we didn't have a designation for interstellar body, so we created one, I, and because this was the first object, we call it I-1. Dr. Weryk, who discovered I-1, wanted to dedicate this to people of Hawaii, the culture of Hawaii, and the sacred land of Hawaii. So we contacted Hawaii cultural practitioners and Hawaii linguistics, and they came up with the name Oumuamua. Oumuamua in a Hawaiian language roughly translates to messenger from afar.
A few days after the discovery of Oumuamua, Weryk, Wainscoat, and Meach calculated the trajectory of the mysterious visitor, and researchers began to build a basic profile.
So after a week of observations, we knew a few things about the object. The average radius of the object was about 102 meters. It was coming in fast, almost 100,000 kilometers per hour, and so that, combined with the shape of the orbit, tells us that it was coming from outside the solar system. The next easiest thing to really understand is its color, measuring its brightness as a function of wavelength. And this showed us that it's very red. We also got an aspect of its rotation because the brightness was going up and down approximately every 8 hours or so. And that tells us it's rotating in space. We see it by reflected light. And so that gave us a brightness maximum and minimum that tells us it's very elongated, almost a factor of 10 to 1. So instead of an average radius of 102 meters, it was more likely 800 by 80 meters in dimension. We also saw no dust and no gas from the object, so it looked very much like an asteroid.
Patrick Michel, an astrophysicist at the Côte d'Azur Observatory in France, is a leading specialist in comets and near-Earth asteroids. He is a member of the pilot committee for the International Warning Network for asteroids which risk colliding with our planet.
The discovery of Oumuamua was a huge event for the astronomical community. Our models predicted that we would discover an interstellar object, even though this is a much rarer occurrence than the discovery of asteroids and comets orbiting the Sun. What we did not expect was that Oumuamua's orbit would divide so many astronomers on the question of its composition and its origin. Some even believe that it's an artificial object sent by alien intelligence.
The day of this week's State of the Union speech, the #1 story at the Washington Post website had nothing to do with politics. Instead, it concerned this multi-sided object spied in the Milky Way, given the name Oumuamua. Harvard's top astronomer says an alien ship may be among us, and he doesn't care what his colleagues think. You are not saying that there's definitely alien life among us. What are you saying?
We are saying that this is the very first interstellar object, an object that came from outside the solar system that we have seen near the Earth. and it looks nothing like the asteroids or comets that we have seen before in the solar system. It has an extreme shape. It deviated from an orbit that is shaped just by the sun's gravity, and it looks shiny and quite unusual. So we say perhaps it was manufactured by some alien civilization. Perhaps it is a spaceship or a probe. We have to put that possibility on the table.
During its 11 weeks of being observed, followed by years of data analysis, Oumuamua's shape remained unclear. To the untrained eye, Oumuamua looks like just another point of light among many. But to astronomers, this mysterious visitor is a surprise, which raises both questions and concerns. Sean Raymond is an American astronomer posted to the Bordeaux Astrophysics Laboratory. His research studies the formation of planetary systems in the Milky Way, the origins of interstellar objects, and exoplanets. His studies have contributed to our understanding of Oumuamua.
Le soleil éclaire tous les planètes du système solaire, ainsi que tous les petits
comets. The sun's light touches all the planets in the solar system, as well as comets, asteroids, and the like. This light reflects off the angular surfaces of these bodies, and that can give us an idea as to the shapes of these objects. Take this spherical ball. When it spins around its axis.
Quand elle tourne, elle tourne sur elle-même.
It always catches the same quantity of light, so we don't see a change in how brightly this object would shine in the sky. However, if I take a ball with an irregular shape, we see that it doesn't always catch the same quantity of sunlight. So we see light variations in this object.
So
this means that the light variations we see in small bodies directly tell us about their shape.
Initial observations revealed that Oumuamua's light signature increased and then diminished in regular intervals. These light variations provide valuable data on how it behaves.
For Oumuamua, we were able to observe its luminosity across time, and that's what we see here. It shifts here, and then we see the object turning, rotating in space every 7 to 8 hours. Remember the experiment we did with the ball? So a spherical ball, when it turns on its axis, still has the same surface, so the light curve off the ball is completely flat.
But
in the case of this rugby ball, with its irregular shape, we see a surface that changes over time as it turns. So here we would see oscillations as here. However, with Oumuamua, the range of these oscillations is much greater than what we'd see on a rugby ball. So here it's 10 times brighter than at the bottom. So what does that mean? It means that Oumuamua is very stretched out, around 10 times longer than it is wide. So how big is Oumuamua? That's what the Spitzer Space Telescope can tell us.
The American Spitzer Space Telescope, launched in 2003, observes the universe through infrared light, which is sensitive to heat emitted by spatial objects. When Oumuamua entered its field of vision, Spitzer did not detect it because the heat accumulated by Oumuamua during its orbit close to the Sun was insufficient.
Qu'est-ce que ça veut dire?
This means that Oumuamua is slightly smaller than we thought. It's not longer than around 100 meters, no wider than around 10 meters. This leaves us with two possible shapes. It's either the shape of a cigar or the shape of some kind of pancake. In either case, this is a unique object.
Exceptionnel, c'est quelque chose qu'on n'aurait jamais vu avant.
Initial studies described it as a long, rocky cylinder, spinning around its own axis, traveling at insane speeds through the solar system. Other data sets suggest that it is a rocky disk around 100 meters wide that is as flat as a pancake. A stone cookie, unlike anything we've ever seen, behaving in a strange manner.
Like most researchers, at first I supported the idea that Oumuamua was just an asteroid of a slightly unusual shape. But then we got a chance to study its trajectory better, and we found an anomaly. And this anomaly was enough to start questioning the nature of this object.
Challenging established ideas is central to scientific research. Instead of discouraging scientists, new data drives their curiosity more than anything else. Marco Micheli was one of the two astronomers that Robert Weryk called when he discovered something strange in the images captured by the Pan-STARRS telescope.
We can use the laws of physics to predict the motion of any object in the solar system. So in this case, we took all the data we have collected with the biggest telescopes in the world, the Hubble Space Telescope, VLT, CFHT, and used them together with the laws of gravity and the gravitational attraction of the sun, the planets, the asteroids, to compute the predicted motion of Oumuamua. And we saw that there was a little discrepancy between our prediction and the observations that we have. The motion of the object deviated from the normal gravitational trajectories as if it was pushed by some kind of force, a radial force repulsive away from the sun. And this force is actually something we call non-gravitational force, and it's pretty common in the solar system because we see it all the time on comets. The thing is that Oumuamua, apart from this particular motion anomaly, did not look like a comet, it looked like a normal asteroid.
Oumuamua looks like an asteroid, but behaves like a comet. The portrait is getting more complicated. Asteroids are made up of rocks, metals, and ice, the same materials that formed the planets. Most of them orbit in a belt between Mars and Jupiter. The smallest ones are hard to observe because, unlike comets, they are faint and have no visible tail. Asteroids can only be spotted by a select few, whereas comets enjoy a large audience.
Only a few of us scan the sky attentively, but everyone can admire comets. Halley's Comet was first observed in the 7th century BCE in China.
This comet has been known to humanity for centuries. As it orbits around the sun, it unfurls its long tail of light across the skies every 76 years.
Et leur luminosité provient du fait que ce sont des agglomérats constitués de nombreux éléments.
Their luminosity is due to the fact that they're made up of several elements. Frozen water, volatile elements such as carbon, methane, and ammonia make up these comets. And when they pass close to the sun, the frozen water sublimates, transforming directly from a solid state to a gaseous state, which gives this beautiful effect when it pumps out large quantities of matter and gas. And we call this a comet's tail since it ends in a tail, and this tail acts as a rocket engine. As a result, the discharged matter adds additional acceleration to the comet, and so comets follow a different trajectory to bodies that are only subject to the gravitational pull of planets. They accelerate due to this quantity of discharged matter. And in the case of Oumuamua, the real problem is that Oumuamua seems to show signs of acceleration, but we're not seeing any trace of this degassing effect.
As it approached the sun, Oumuamua accelerated like a comet. But unlike a comet, it left no visible trail. To shed light on this mystery, several hypotheses have been proposed. Oumuamua could be a hydrogen iceberg drifting through space, or a fragment from an exoplanet similar to Pluto. As enticing as they may be, none of these theories have truly convinced the astronomical community. That is, until the arrival of astrophysicist Darrell Z. Seligman from the University of Colorado Boulder, a specialist in small celestial bodies, exoplanets, and plasma physics in relation to objects crossing the solar system, which also behave in unexpected ways.
After the discovery of Oumuamua's non-gravitational acceleration, we went back and looked at the trajectories of asteroids in the solar system, particularly the near-Earth objects, the asteroids that get close to the Earth. And we noticed that a number of these asteroids, including 1998 KY-26, were not behaving as expected. So by analyzing their trajectories, we found that 7 of these near-Earth objects exhibit significant non-gravitational accelerations, like Oumuamua, but with no dust coma or outgassing detected. So therefore we have these 7 objects which are asteroids which behave like comets. So I called them dark comets, and specifically I called them dark because there is no dust coma whatsoever. So given the similarities observed between Oumuamua and the dark comets, specifically the non-gravitational accelerations but no dust coma and no outgassing observed, there's a natural question which arises, which is, could Oumuamua be a dark comet?
The hypothesis that Oumuamua is an interstellar variant of the dark comets observed elsewhere in the solar system opens up new research into comet behavior. Sean Raymond explains this with an inspiring astronomical cooking demonstration.
Donc on va commencer en rajoutant de l'eau.
We'll start by adding water.
Ça, c'est l'ingrédient principal. On va rajouter un peu comme ça. Ensuite, des roches.
Then rocks.
Du sable.
We'll use sand, as well as a little bit of charcoal. Comets are very black.
Parce que les comètes sont très, très noirs. Okay. Là, ce que nous allons faire,
we're going to add carbonized ice.
La glace carbonique directement là-dedans. Voyez, ça,
you see the smoke?
Un peu plus.
Now we'll form the heart of this comet.
Former ce noyau cométaire, comme on dit. Voyons.
Let's see what we get. See that?
Okay, voyons ça. Ouh là là.
This is the comet we've just cooked up. So what do we see? We see lots of vapor coming out of everywhere. This is water vapor, but also CO2 vapor due to the dry ice we added.
Mais aussi de la vapeur de CO2 à cause de la glace carbonique que nous avons mis là.
And we can see that the surface of the comet is very black, very dark. All comets are like this. They have very dark surfaces. And we think that dark comets have very, very dark surfaces.
Et donc, dans ce cas-là, comme je disais, on voit la vapeur d'eau.
In this case, as I said, we see the water vapor coming off. However, we know that the water vapor doesn't give off enough energy to explain Oumuamua's non-gravitational acceleration. So we're wondering, what fuel could be propelling it through space? This is a very big question which we need to answer.
Auquel il faut qu'on réponde.
Identifying the fuel that is causing Oumuamua to deviate is a question that goes beyond astronomy, and it is also puzzling the chemists. So Seligman has turned to Jennifer Bergner, a Harvard graduate and chemistry professor at the famous University of California, Berkeley.
Darrell and I worked together to come up with an explanation that could explain this sort of peculiar non-gravitational acceleration of Oumuamua, but without resorting to any sort of exotic physics or chemistry, just based on what we expect to happen to an interstellar comet that's passed through the interstellar medium for millions of years.
For Jennifer Bergner and Darrell Seligman, Oumuamua could be a variant of a dark comet, made up of porous, powder-like ice, unlike the crystalline ice we have on Earth. Over the course of its long journey in interstellar space, highly intense cosmic radiation would break down most of the water molecules, producing hydrogen trapped in its pores of the powder ice due to the immense cold. When Oumuamua approached the sun, its heat transformed part of the powder ice into crystalline ice, with this conversion freeing up the trapped hydrogen, causing a degassing effect. The previously unexplained force which produced the push responsible for the deviation in Oumuamua's trajectory could therefore be due to hydrogen degassing.
So it's a very natural explanation for Oumuamua's behavior without resorting to any fine-tuned scenarios.
This collaboration between a brilliant young chemist and a high-level astrophysicist has developed a hypothesis which has convinced many in the astronomical community. However, Roman Rafikov, who teaches astrophysics at Cambridge University in the UK, remains skeptical.
I find it a bit hard to believe that the non-gravitational acceleration of Oumuamua is caused by just plain outgassing. In many ways, I think this hypothesis raises more questions than it answers in the first place. In particular, I think it creates some problems regarding the rotational properties of this object. Whether Oumuamua was made of water, nitrogen, or hydrogen, all these materials would melt as it was passing by the sun. And then in the process of doing this, because this outgassing is happening in a very irregular way, and the shape of the object is very irregular as well, it's either cigar-shaped or disc-shaped, this outgassing would then cause not only the linear acceleration of Oumuamua, but also would spin it up or spin it down. So most likely, because of the strong non-gravitational acceleration, these forces that were pushing the object would also actually spin it up to such a high degree that they would destroy it in a matter of several days. And then, after 30 days of observations, what did we see? We still see that Oumuamua has survived its journey through the solar system, and we actually see that its rotational properties remained reasonably stable. To me, its non-gravitational acceleration still remains a big mystery.
One hypothesis is that Oumuamua could be an artificial object, a claim proposed by a few scientists, but widely rejected by the scientific community, even as it attracted significant attention in the media.
In 2017, October, we spotted an object that came from outside the solar system, close to Earth, and it was really the very first one that we encountered. And at first, astronomers thought it must be a comet. However, it didn't show any cometary tail. There was no gas around it. And then it also exhibited an extra push away from the sun. But without a cometary tail, there is no rocket effect. And the question was, what gives it this extra push?
Given the sudden change in Oumuamua's trajectory with no clear cause, it is tempting to think that this enigmatic object could have been created artificially. Avi Loeb suggests that Oumuamua relied on light from the sun in order to change direction. Light unleashes energy in the form of photons emitted by a source. The sun and other stars continuously emit streams of photons into space. Although they have no mass, photons carry energy and can put pressure on objects in their path. For sunlight to alter Oumuamua's trajectory, Loeb thinks the comet would have to be around 100 meters long and less than a millimeter thick. We're a long way from cataloging every single object crossing through space, but Loeb concludes that it seems highly unlikely that a 100-meter-long object under 1 millimeter thick exists in a natural state, which raises the possibility that it was artificially made. The idea of extraterrestrial life has long been discussed. Out in the infinite universe, there could exist other inhabited worlds. In the Lassen National Park in Northern California, The 42 satellite dishes of the Allen Telescope Array have been scanning the skies since 2007.
Before, people thought we were looking for little green men. But since then, SETI research has become more widely available. There are now a large number of researchers and engineers who helped develop better instruments.
This line
represents the technological signature of the Voyager probe. The Allen Telescope Array didn't detect this kind of signal, though. So we don't think Oumuamua contains technology.
Avi Loeb objects, saying that Oumuamua could be inert debris from a wrecked spaceship hurled into space.
A large majority of researchers reject Avi Loeb's hypothesis, but we cannot outright refute that Oumuamua could be debris from an extraterrestrial solar sail.
The arrival of an object fabricated outside Earth would fundamentally change our understanding of the universe. But this remains unlikely. Faced with a question which remains unanswered, even after long and extensive investigations, the scientists aren't backing down. In 2019, 2I Borisov, another interstellar object, was spotted. For Andreas Hein, professor of spatial engineering at the University of Luxembourg, it's a motivation to continue.
We mustn't give up. Given its unique characteristics, Oumuamua is an object that holds immense scientific value and a chance to better understand space beyond our solar system. Despite the immense distances, 2I Borisov showed us that there are exchanges between stars in the Milky Way. The red color of both Oumuamua and 2I Borisov indicate a composition that is potentially rich in organic ingredients, which are the building blocks of life. This is very interesting. Could these exchanges be carrying life?
If life was brought to Earth by objects such as Oumuamua and 2I Borisov, this means that after having crossed Earth's atmosphere, these asteroids and comets would have hit the ground or the ocean. What impact would Oumuamua and 2I Borisov have had if they had collided with our planet?
Oumuamua passed by 25 million kilometers from Earth, which seems huge, but once you understand that it's undergone an interstellar journey of many millions of years, it's not that much. Would just one small variation have been enough for Oumuamua to hit the Earth? And what would have been the consequences? If we take a classic asteroid the same size and mass as Oumuamua, the impact energy would have been 24 megatons, which is the equivalent of 1,700 Hiroshima bombs. Whereas a classic asteroid hurtling towards Earth travels at a speed of 15 to 17 kilometers per second, and knowing that an object's impact energy increases by the square value of its speed, and that the maximum speed reached by Oumuamua due to solar disruptions was 87 kilometers per second. Well, if Oumuamua hit the Earth at that speed, the impact energy would have been 6,700 megatons, the equivalent of 45,000 Hiroshimas. A large part of France would have been wiped off the map. And if we take Borisov, 5 times the size of Oumuamua, the impact energy would be 1 million Hiroshimas, which would destroy a large part of Europe.
The violence of the meteorite that fell into the Gulf of Mexico 66 million years ago left its mark in the quartz there, which reveal the traces of an enormous impact. A gigantic volume of dust encircled the planet in a toxic darkness, heralding a deadly winter. If such an impact took place today, densely populated cities would be erased and infrastructure would be destroyed. The Fukushima tsunami gives an idea of the devastation that coastal zones would suffer. Although Oumuamua and 2I Borisov passed relatively far off the mark, there is no guarantee that they will always do so. Are we able to protect ourselves from an interstellar visitor hurtling straight at us?
Non. Nous n'avons pas les moyens de réagir rapidement à l'arrivée d'un astéroïde sur Terre.
No, we can't rapidly react to an asteroid heading towards Earth, but we're working on it. In November 2021, we launched the DART probe to Didymus and its small moon Dimorphos. The goal was to test the effects of DART's collision with the small moon. In September 2022, we sighted Didymus, and on September 27th, the 770-kilogram probe hit the small moon at 24,000 kilometers per hour, and in this recording we see this final image taken by the probe's camera before impact. It gets closer, accelerating right until the final frame, which doesn't reach the ground since the probe exploded. It was an extraordinary success. Here's an image of DART's impact with Dimorphos taken from Earth with a telescope. And bingo! A few weeks later, we measured that the impact was able to shift the asteroid out of its initial trajectory, which is absolutely extraordinary. Right now, we're a long way from being able to neutralize objects the size of Oumuamua and Borisov. And first, we need to be able to detect them far enough in advance in order to be able to act.
If Oumuamua had been on an Earth-impacting orbit, it isn't 100% certain that we would have found it before it hit. The truth is, we kind of got lucky. We were looking in the correct direction on the correct night, even though the weather wasn't that great. If Oumuamua had been on an Earth-impacting trajectory, the time between when it was discovered and when it would have impacted would have been very small.
Plus on intervient en amont, moins il faut d'énergie pour écarter le danger.
The earlier we intervene, the less energy is needed to remove the danger. If we do this very late, only a probe loaded with a nuclear bomb could save us, and interstellar objects are dangerous. They're difficult to detect in advance since they move at extremely high speeds, and we don't know how many have entered the solar system.
À pénétrer le système solaire. Concernant 2I Borisov, nous savons que c'est une...
We know that 2I Borisov is a comet. As for Oumuamua, it's still a mystery. We don't know its origin, its composition, or if it carries the building blocks of life. We've made hypotheses, some more plausible than others, but we will never be able to verify them. Oumuamua has set off into interstellar space for good.
Pour résoudre l'énigme Oumuamua,
to resolve the Oumuamua enigma, we need more Oumuamuas. The good news is the deployment of the Vera Rubin telescope should allow us to detect them a lot earlier, with longer observation time and improved quality. And in 2029, the European Space Agency will launch its Comet Interceptor mission, which could search for an interstellar object to study up close. With all these measures, interstellar objects will reveal their secrets.
A Comet Interceptor probe is set to be launched in late 2029. After traveling 1.5 million kilometers, it will be positioned in a standby orbit. When a suitable target is identified by the Vera C. Rubin telescope, the Comet Interceptor will intercept it and get close enough to create a detailed 3D portrait. The program will also study objects from interstellar space, such as Oumuamua and 2I Borisov.
Le problème est que la probabilité de détecter un objet interstellaire qui
The problem is the probability of detecting an interstellar object which fits the targeting parameters of a Comet Interceptor mission is low. We risk letting lots of Oumuamuas pass us by before being able to observe one up close. For now, Oumuamua remains unique. The only way to resolve the Oumuamua mystery is to catch it, and that's still possible.
Et c'est possible.
With a team of researchers and engineers, we're working on Project Lyra. In about a decade, it will be possible to develop and send out a spaceship to intercept Oumuamua and photograph it. We will then know without any shadow of doubt what it is.
We've
done all the trajectory and speed calculations that a spaceship would need to catch up to Oumuamua. This spaceship will be built with technologies that already exist or are currently in development. This represents a sizable challenge, notably due to the high speed of Oumuamua. In order to send out a spaceship to intercept Oumuamua, we have until 2035 to 2040 to develop it and launch it into space. There are 3 possible types of machine.
The most innovative and cost-effective technology would be a space probe equipped with a solar sail. The initial acceleration would be provided by energy from a high-power laser installed on Earth. Powered by its solar sail, the probe could reach speeds of 300 kilometers per second, 10 times the speed of Oumuamua. If it were launched in July 2030, it would reach Oumuamua in just over a year.
Incredibly, it would only take 440 days to find out if Oumuamua is a dark comet, a piece of a Pluto-like exoplanet, or a piece of extraterrestrial technology.
Le mystère d'Oumuamua reste entier. En fait, on n'a pas réussi à résoudre.
The Oumuamua mystery remains, but thanks to Oumuamua, we've considered ideas we never would have, like the role of dark comets carrying water and elements which could have contributed to life emerging on Earth.
Permis à la vie d'émerger sur Terre.
If we manage to catch Oumuamua or land a probe on the next one, like we did on the Chury comet, then we'll be able to read the messages they carry from one end of the galaxy to the other. We'll have opened a path to the stars.
The public usually hears of science in the news only when a major discovery is announced, when we know how it will impact humans. Oumuamua, the messenger from afar in the Hawaiian language, reminds us that science is a long, patient process of investigation, experimentation, and data analysis. Research into new approaches often leads to temporary or real roadblocks, but researchers are never discouraged. If a hypothesis doesn't pan out, they put their work to one side, and often years later, in a completely different context, someone else may benefit from it. Astronomy is an expression of humanity's insatiable curiosity and its hope of discovering signs of unknown life in the universe with which we could one day, perhaps, make contact.